A conducting liquid bubble of radius a and thickness t, t being very smaller than a, is charged to a potential V. If the bubble collapses into the droplet, find the potential of the droplet. Okay. First of all, I can say that the potential of the droplet, if I take a bubble, okay, let me start with the bubble. Its thickness is very small, t is very small as compared to the radius a. Okay. So the potential of this bubble V will simply be equal to kq divided by a. Okay, simply be equal to kq divided by a. Okay, for this liquid droplet. Okay, as it collapses into a very small drop. Okay, as it collapses into the very small drop, first of all, the volume of this bubble will be equal to the volume of this drop. So how to find out the volume of this bubble? It will be equal to the surface area. Curved surface area is equal to 4 pi a square into its thickness. Thickness over here is equal to t, is equal to the volume of the droplet. The volume of the droplet is equal to v dash. Okay, let me the volume over here, it will be equal to 4 by 3 pi r cube, where r is the radius of the drop. Okay, so if I substitute this value, okay, capital R cube, okay, 4 pi will get cancelled out. Capital R cube will be equal to 3a square t, or capital R over here will be equal to 3a square t the whole raised to 1 by 3. Okay, let this be equation number 2. We will use this later. Okay, now the charge remains same. Now the charge remains same in both the droplet as well as the bubble. The charge remains same because of the law of conservation of the charges. So v dash, let it be equal to v dash. For the droplet, it will be equal to kq divided by r. Okay, it will be equal to kq divided by r, where r is the radius of the bubble. So v dash divided by v will be equal to kq will get cancelled out. Capital R, it will be equal to a divided by capital R. Now capital R over here is equal to we have to find out the potential of this droplet. Okay, so capital R over here will be equal to a is given like this. Okay, 3a square t raised to the whole raised to 1 by 3. Okay, when I take this inside the bracket, when I take a inside the bracket, it will be equal to a cube divided by 3a square t the whole raised to 1 by 3. So basically the square and the cube will get cancelled out over here, and the value of v dash by v will come out to be a divided by 3t the whole raised to 1 by 3, or I can say that v dash, the potential on the drop, will be equal to v a divided by 3t the whole raised to 1 by 3. This will be the total potential developed on the drop.